Hi everybody, let us solve this conceptual question in electrostatics. The question is, can the following represent static electric lines of forces? Here on the first question, we are given several straight lines which are parallel to each other. We see that in this, let's say region A, the electric lines of forces are not densely populated, which means they are a bit less concentrated. Whereas in this region, let's say it's region B, where the electric lines of forces are pretty densely packed, or their concentration is high. As we already know that the electric lines of force, if their concentration is high, it means the field strength is high. So we can say that electric field strength at B is greater than electric field strength at A. Now let us draw a perpendicular like this. We know that perpendicular to the electric lines of forces is the equipotential line. So this L is an equipotential line, which means any point, let's say P and Q, must satisfy that BP is equal to PQ. However, we see that if I'm going to move a elementary charge, let's say plus dq or q, from point P to point Q, I will have to do some work because the forces experienced at point P and at point Q are not the same. Why? Because the electric field strengths are not the same. Hence, this is a contradiction, and this setup cannot represent electric lines of force. Similarly, coming to the second diagram, we see that the lines of forces are making a sharp turn here, which is, let's say, 90 degree for several of them. We see that any point for the points on this edges now, here, if I put a elementary charge, a point charge q, it will experience forces in two different directions which are tangent to this point, right? So we could say that here the q would be experiencing force in this direction, let's say q into strength of the field here, and here also q into strength of the field. This is also not possible because at one point we must experience the elementary charge must experience force in one direction. Thank you very much for watching. So we can also say that this is also not a static electric lines of forces. Thank you.